Interpretation of regression analysis with solved example based on MS Excel and mathematical formulas. Table of contents. 1. Example of regression analysis. 2. How to compute and interpret diverse measures of regression analysis by MS Excel and mathematical formulas. Draw and interpret numerous graphs, i.e. residuals plots, standardized residuals, line fit plot, also called as scatter plot, and normal probability plot. Example of regression analysis. Management of a soft drink bottling company has the business objective of developing a method for allocating delivery costs to customers. Although one cost clearly relates to travel time within a particular route, another variable cost reflects the time required to unload the cases of soft drink at the delivery point. To begin, management decided to develop a regression model to predict delivery time based on the number of cases delivered. A sample of 20 deliveries within a territory was selected. The delivery times and the number of cases delivered were organized in the following table. Here is the data of 20 customers regarding independent variable, which is number of cases X, and dependent variable, which is delivery time Y. Here is the requirements of example from Part A to Part G in order to calculate all measures of regression analysis such as model summary, ANOVA, significance of F-test and T-test, and also their graphs. After installation of add-ins and selecting all required fields in regression in data analysis for Y-range and X-range, labels, confidence level 95%, numerous plots such as residuals, residuals plots, standardized residuals, line fit plot, also called as scatter plot, and normal probability plot. After selecting your required plots, you will press OK. The above is the result of regression analysis, which have two parts such as summary output and analysis of variance, ANOVA. Calculations of nominators and denominators for short and long formulas, which is used in numerous measures of regression analysis based on MS Excel formulas. Excel used n instead n-1 to get accurate answer. Covariance is equal to summation of x bar subtract from xi and y bar subtract from y divided by n by putting values of sigma xi minus x multiply b y minus y bar is equal to 17,450.0500. Thus, covariance is equal to 875.5025. MS Excel formula of covariance is given for help to get same answer is computed by MS Excel. It is important tip that MS Excel use n instead n-1 in denominator of covariance formula. Interpretations: the value of covariance of xy is equal to 872.5025, which is positive and indicate the direction of the linear relationship between number of cases, x, and delivery time, y. Its range is negative infinity less than or equal to covariance of xy, which is less than or equal to positive infinity. It is non-standardized in nature. It is less used in research and considered as supporting measure to compute correlation coefficient. The standard deviation of independent variable and dependent variable is equal to whole under root of sum of squared deviation divided by sample size by putting values in standard deviation of independent variable and dependent variable formulas. We get standard deviation of independent variable is equal to 78.9366 and standard deviation of dependent variable is equal to 11.2127. MS Excel formula of standard deviation of x and standard deviation of y are given for help to get same answer is computed by MS Excel. Interpretations: it measure of how dispersed the data is in relation to the mean. A standard deviation close to zero indicates that data points are close to the mean, whereas a high or low standard deviation indicates data points are respectively above or below the mean. In our example, the standard deviation of delivery time, y, is 11.2127, which is lower than the standard deviation of number of cases, x, which is 78.9366. The higher the standard deviation, the higher will be spread out as compared to lower standard deviation. Formula of coefficient of correlation, R, is equal to covariance of x and y divided by standard deviation of x and standard deviation of y. By putting values we get R is equal to 0.9858. MS Excel formula of covariance, standard deviation of x, standard deviation of y and coefficient of correlation, R, are given for help to get same answer computed by MS Excel. Interpretations: it measures both strength and direction of the linear relationship between x and y. Its range is -1 is less than or equal to R, which is less than or equal to 1. In our example, the value is close to 1 and positive, which means strongly positive correlation is found between number of cases, x, and delivery time, y. Coefficient of determination, R squared, is equal to subtracting SSE divided by SST from 1. Alternatively, coefficient of determination, R squared, is equal to dividing SSR by SST or by taking square of coefficient of correlation R. By putting values of SSE and SST in formula, we get R squared is equal to 97.18%. 3 MS Excel formula of R squared are also given for help to get same answer as computed by MS Excel. Interpretations: it can measure goodness of fit test of simple linear regression model. Its range is 0 less than or equal to R squared, which is less than or equal to 1. R squared is 1 for a perfect regression and 0 for a completely useless fit, no correlation between y and x. It is explained variation of model and can tell us that 97.18% independent variable, delivery time, are explained by independent variable, number of cases. 97.18% values falls on regression line and remaining are unexplained variation, which is 2.82%, which goes to error term of model and fall away from regression line above and below. In regression analysis, the value of R squared is non-negative, pure and dimensionless number because our model is not from origin. Adjusted R bar squared is equal to subtracting SSE by n-k further divided by SST divided by n-1 from 1. By putting values of SS residuals and SS total, sample size n and no of variables k, we get adjusted R bar squared is equal to 0.9702. MS Excel formula of adjusted R bar squared is also given for help to get same answer as computed by MS Excel. Interpretations: it is often used to summarize the fit of the model as it takes into account the number of variables in the model. It is used to compare models with different sets of independent variables in terms of predictive capabilities and penalizes models with unnecessary predictors. The adjusted R bar squared decreases due to useless variables in model and increases due to useful variables. If adjusted R bar squared is low, it does not mean that model is bad and unfitted. Moreover, it is modified version of coefficient of determination, R squared, and adjusted to number of predictors in model. In short, the scholars tend to prefer R squared instead adjusted R bar squared. Adjusted R bar squared value decrease if independent variable is insignificant and increases if independent variable is significant. Standard error of regression is equal to whole under root of sum square error or divided by n-2 or sum of y minus y cap square divided by n-2 whole under root. MS Excel formula of standard error of regression are also given for help to get same answer is computed by MS Excel. Interpretations: the standard error of regression measures the variability of dependent variable relative to the regression line. Standard error of regression is computed by taking whole square root of sum square error, SSE, divided by n-2. Hence, the variability of delivery time, y, is relative to regression line is 1.9865%. The value of standard error of regression is 1.9865%, which is less than 5% level of significance. Moreover, the interpretation of standard error is same as standard deviation. Just as the standard deviation measures the variability around the mean while the standard error of regression measures the variability around the regression line or prediction line. The number of observations are 20 in this example. Degree of freedom of SSR is equal to number of total variables k-1. By putting values we get degree of freedom of SSR is equal to 1. Degree of freedom of SSE is equal to sample size n minus number of total variables k. By putting values we get degree of freedom of SSE is equal to 18. Degree of freedom of SST is equal to sample size n-1. By putting values we get degree of freedom of SST is equal to 19. MS Excel formula of degree of freedom regarding SSR, SSE and SST are also given for help to get same answer is computed by MS Excel. Interpretations: the degrees of freedom refers to the maximum number of logically independent values, which are values that have the freedom to vary, in the data sample. In statistics, degrees of freedom indicate the number of independent values that can vary in an analysis without breaking any constraints. It is an essential idea that appears in many contexts throughout statistics, including hypothesis tests, probability distributions, and regression analysis. Thus, degree of freedom is the effective number of parameters of the regression model. In our regression example, k is equal to 2 and n is equal to 20. Method 1. Calculations of long formulas for SSR, SSE and SST are given in this slide. MS Excel formula of SSR, SSE and SST are also given for help to get same answer is computed by MS Excel. I will share one of important tip, which is only calculate SSE and SST and subtract SSE from SST to get value of SSR. It will save lot of time. Examiner is interested in your answer, which is based either on short or long formula, but not interested in your lengthy calculations. Interpretations: SSR is the sum square of the differences between the predicted value and the mean of the dependent variable. It describes how well our line fits the data. If this value of SSR is equal to the sum squares total, it means our regression model captures all the observed variability and is perfect, which is explained variation. SSR is 2443.4660, which is slightly close to SST, which is 2514.4975. By dividing 2443.4660 by 2514.4975 multiply by 100, we get explained variation is 97.18%, which is R² given in summary part of regression analysis. SSE is the sum of squares difference between the observed value and the predicted value of dependent variable. It is unexplained variation of mode. SSE is equal to 71.0315 while total variation is 2514.4975. Interpretations. SSE is sum square of the difference between the observed value and the predicted value of the dependent variable. It is the unexplained variation in delivery time, y, attributable to factors other than number of cases, x. We usually want to minimize the error. The smaller the error, the better the estimation power of the regression. SSL value is 71.0315. By dividing 71.0315 by 2514.4975 we get unexplained variation of model which is 2.82%. SST is the sum squared differences between the observed value and mean of the dependent variable. You can think of this as the dispersion of the observed variables around the mean. It is a measure of the total variability of the dataset. By adding SSR value of 143.4660 and SSE value of 71.0315 to get SST value of is 2514.4975. Thus for SST, variation in percentage are added for both explained and unexplained variation which is 97.18 and 2.82% to get 100% value of SST in percentage. Method 2. Calculations of short formulas for SSR, SSE and SST. If you know Thesis short formulas for SSR, SSE and SST you can save lot of time for completing ANOVA table. MS Excel formula of SSR, SSE and SST are also given for help to get same answer as computed by MS Excel. Interpretations is explained previously. This slide is just for short formulas of SSR, SSE and SST. Method 3. Calculations of short formulas for SSR, SSE and SST. It's my personal and short notes. You get all answers is computed by mathematical or MS Excel formulas. This method will help you if data, R² and standard error of regression is given, then we will calculate all values in summary and ANOVA part of regression analysis in just 5-minute time by ignoring lengthy steps that takes almost an hour. No idea you will get correct answer or not if you do it manually. So, I will tend to prefer method 3 which takes only 5-minute time to compute all measures of summary part and ANOVA. MSR is equal to dividing SSR by k minus degree of freedom. By putting values, we get MSR is equal to 24,043.4660. MSE is equal to dividing SSE by n minus 2 degree of freedom. By putting values, we get MSE is equal to 3.9462. MS Excel formula of MSR and MSE are also given for help to get same answer as computed by MS Excel. Interpretations. MSR is the nominator of F-test with k-1 degree of freedom. In simple linear regression model, MSR is equal to SSR due to k is equal to 2 variables used in regression analysis. MSE is the denominator of F-test with n-2 degree of freedom. I will share one tip for calculating standard error of regression or residuals by taking square root of MSE gives standard error of regression or residuals which is given in summary part of regression analysis. By putting values of MSR and MSE we get F-test value is equal to 619.56. MS Excel formula of F-test are given for help to get same answer as computed by MS Excel. Interpretations. It is a measure for the strength of the regression model. A strong relationship between x and y gives a high value of f-test. In our example, the f-test value is equal to 619.56, which is a signal of high relationship between number of cases and delivery time. Tip: to get answer same as MS Excel, you will not round up the value of r square, you have to write the full value till 9 digits after decimal. F-test value is not fall in any 2 value in 95% F distribution table because it too large. We will tend to prefer critical range approach to find either reject or accept the hypothesis. The critical value of F-test is 4.41 with 5%. Degree of freedom 1 is 2 minus 1 is equal to 1 and degree of freedom 2 is equal to 18. Thus, F-test is equal to 619.1956 in acceptance region, which is greater than F critical value of 4.41. MS Excel formula of p-value and critical range value is given for help to get same answer is computed by MS Excel. Interpretations: the p-value of F-test is 0, which is less than 5% level of significance. Therefore, we reject null hypothesis, which is h not beta is equal to 0, and concludes that slope coefficient are not equal to 0, h1 beta is not equal to 0. Thus model is useful, valid and significant. Slope of t-test is computed by multiply r by standard deviation of y divided by standard deviation of x. By putting values, we get bet1 is equal to 0.1400. MS Excel formula of slope of t-test are given for help to get same answer is computed by MS Excel. Interpretations: the slope is the estimated change in the mean value of y as a result of a 1 unit increase in x. Y is equal to intercept plus sine slope multiply by x. Thus delivery time is equal to 23.8345 plus sine 0.1400 multiply by number of cases. If 1 unit increase in number of cases, then delivery time will be increased by 0.1400. Further, if intercept constant is positive, then delivery time also increase by 23.8345, otherwise reduce if intercept value is negative. It's the nominator of t-test. For intercept of t-test, we subtract product of slope multiply by sum of x from sum of y divided by n. Alternatively, intercept of t-test is also equal to subtracting product of slope and mean of x from mean of y. By putting values, we get intercept is equal to 24.8345. MS Excel formula of intercept of t-test is given for help to get same answer is computed by MS Excel. Interpretations: the intercept is the estimated mean value of y when the value of x is 0. In simple words, intercept means that if x is equal to 0, then y is equal to 24.8345. Y is equal to intercept plus slope multiply by x. Thus delivery time is equal to 23.8345 plus sine 0.1400 multiply by number of cases. Hence, delivery time is equal to 23.45. It's the nominator of t-test. Standard error of beta1 is equal to dividing standard error of regression by square root of sum of squared difference around the mean. By putting values, we get standard error of beta1 is equal to 0.0056. Standard error of beta naught is multiplying standard error of regression by square root of sigma x squared dividing by sample size and sum of squared difference around the mean. By putting values, we get standard error of beta naught is equal to 1.0542. MS Excel formula of standard error of slope and intercept are given for help to get same answer is computed by MS Excel. Interpretations standard errors for regression are measures of how spread out your y variables are around the mean, mu. The standard error of slope shows the average distance that your observed values deviate from the regression line. The smaller the standard error of beta 1 value, the closer your values are to the regression line. The standard error of intercept allows us to test whether or not the estimated intercept is statistically significant from a hypothesized value of 0. The standard error of beta 1 and standard error of beta naught measure the precision of estimate of coefficient. The smaller the standard error, the more precisely the estimate will be. Both standard error of beta 1 and standard error of beta naught are denominator of t-test and always positive. By dividing the coefficient by its standard error gives t-test value. By putting value slope and standard error of slope in t-test formula, we get value of t-test for slope is equal to 24.8836, and putting values of intercept and standard error of intercept in t-test formula, we get t-test for intercept is equal to 23.5573, respectively. MS Excel formula of t-test of slope and intercept are given for help to get same answer is computed by MS Excel. Interpretations t-distribution is used when data are approximately normally distributed, which means the data follow a bell shape but the population variance is unknown. The variance in a t-distribution is estimated based on the degrees of freedom of the dataset, total number of observations minus 1. The t-test in regression is used to test hypothesis based on its p-value, confidence interval approach or critical range approach. Note: t-test of slope is equal to square root of f-test value of 619.1956 gives t-test is equal to 24.8836 for slope in only simple linear regression model instead multiple linear regression model. In t-distribution you will select t-test value which is in between two values in table. Thus, t-test of slope value is 24.8836 and t-test value of intercept is equal to 23.5573 falls in 12.7062 and 31.8207. By putting all these value we get values of p-value of t-test of slope is 0.015 and 0.0004, slightly close to MS Excel results and significant at 5%. For intercept p, value of t-test is 0.0165 and 0.0015. In both case alpha are less than 5%. MS Excel formula of p-value calculation of t-test are given for help to get same and significant answer is computed by MS Excel. Interpretations in both cases, p-value of TTS is 0.0154 and 0.0004, which is less than 5% level of significance. Hence, we reject H0 and conclude that there is positive and significant association between number of cases and delivery time. For intercept, there is no hypothesis but p-value seems significant at 5%. We can't write like this, that is, there is positive and significant association between intercept, constant, and delivery time. By putting value in slope and intercept formulas of 95% lower and upper bounds we get values the slope is equal to 0.1400 falls between 95% lower and bound the intercept is equal to 24.8345 falls between 95% lower and upper bound. MS Excel formula of 95% confidence for slope and intercept are given for help to get same answer is computed by MS Excel. Interpretations. In both cases, slope is equal to 0.1400 and intercept is equal to 24.8345 are positive and falls in lower and upper 95%. Thus, slope is equal to 0.1400 is greater than 0 and 24.8345 is greater than 0 and have positive association in order to reject null hypothesis. In addition, if slope is equal to 0 and intercept is equal to 0 mean signify no association, and slope is less than 0 and intercept is less than 0 signify negative association. By checking values in t-distribution table of 95% at 18 degree of freedom and 0.025 significance level for two-tail test, we get value of 2.1009. MS Excel formula of 95% critical range approach are given for help to get same answer is computed by MS Excel. Interpretations. Sometimes we value of t-test gives misleading results, then we tend to prefer critical range approach to test hypothesis. It is t-test value fall in rejection region we will reject null hypothesis. In both cases shown above, for slope and intercept in which t-test is equal to 24.8836 and t-test is equal to 23.5573 falls in rejection rejoin and which is less than critical range value of 2.1009. Thus, we reject null hypothesis and conclude that there is sufficient evidence that t-test is statistically significant at 5%. MS Excel results of residuals which MS Excel generated automatically. Manual calculation of residuals with formulas. Predicted delivery time is calculated by product of slope and first observation of number of cases and then add with intercept. We just change the number of cases which is independent variable and intercept and slope are same for 20 observation. After press enter we get y cap column. We will subtract it from delivery time y to y minus y cap which is residuals. For standard residual we will find mean of residuals and standard deviation. First standard residual is equal to sum of mean and first residual value divide by standard deviation. You can use this formula for rest of 19 residuals. The residual are given on y-axis and number of cases which is independent variable is on x-axis. The residual plot shows that there is no obvious pattern in the residuals because error are independent and their variances are equal, which mean residual showing homoskedasticity, because there is no heteroskedasticity found in data, so the assumption of regression are met. Scatter plot uses dots to represent values for two different numeric variables. The position of each dot on the horizontal and vertical axis indicates values for an individual data point. Scatter plots are used to observe relationships between two variables. The number of case is independent variable which is given on x-axis and delivery time is dependent variable which is given on y-axis. A scatter plot has points that show the relationship between two sets of variable x and y. In this example, each dot shows number of cases of customer versus their delivery time which shows linear relationship. The data for normal probability plot is given. We compare MS Excel automatic generated results with manual calculations of percentile with formulas. In first percentile, in which we divide 100 by product of 2 with sample size of 20. In next percentile, we use that value of 2.5 or cell value added in second percentile like cumulative till 20 percentile. In second percentile we take first percentile value add with 100 by sample size of 20 to get second percentile value of 7.50. which simply mean by adding 2.5 with 5 gives 7 point. In third percentile we add 7.5 with 5 to get 12.50 value and so on. You can see the values of percentile which are green in color for how to apply formula in MS Excel or manual calculations. The normal probability plot is a graphical technique for assessing whether or not a dataset is approximately normally distributed. The sample percentile is shown on x-axis while dependent variable which is delivery time is shown on y-axis. The graph of normal probability plot shows that dataset is normally distributed. Solution of example: all parts are done except part E and part G. Part E predict the delivery time, y, for 150 cases of soft drink. By putting values in regression equation we get predicted value of delivery time is 45.84. Part G: should you use the model to predict the delivery time for a customer who is receiving 500 cases of soft drink? Why or why not? Answer to this question is no. 500 is outside the relevant range of the data used to fit the regression equation. In next video I will briefly explain how to enter data into scientific calculator in order to get all values of statistical measures, and you have to do reverse calculations easily in just 15-minute time. Please subscribe my YouTube channel Thesis Helper. Thanks for watching.